about variables. I'm going to do it kind of what I would consider the long way. I'm going to show you the shortcut for those of you who can do it, but I'm not going to do the shortcut. Okay? I'm going to make sure you really see what I'm doing. So, the ones we did previously all had even powers, which were a perfect square. We had to divide by 2. If the power is odd, this is how you're going to break it up. You're going to decrease the power by 1. So 7 minus 1 is 6. And then the 1 next to it, so this stuff together gives me my x to the 7th. So take it down by 1, then put the other one left next to it. Together that's 7. And then this is my perfect square. 6 divided by 2 is 3. And then you have the 1 left over. So x to the 13th, I'm going to make x to the 12th times x. Decrease the power by 1, and then the x next to it together makes my x to the 13th. And then 12 divided by 2 is 6, with 1 left over. X to the 35th is going to break to x to the 34th x. So 34 divided by 2 is 17, and then my x left over. X to the 23rd is going to break to x to the 22nd x. (22) divided by 2 is 11, with my x left over. So as I have typed here, if the power is odd, you will always have a square root of x left. Always. Now, if I were teaching this in an Algebra 2 class, I would not have written it out like that. I probably would have showed it one time, and then from there, I would have said this. And this is something you can use if you want. I'm going to keep writing it, though. Okay? I would say 2 goes into 7 evenly 3 times, 1 left over. 2 goes into 35 evenly 17 times, 1 left over. 2 goes into 13 evenly 6 times, 1 left over. 2 goes into 23 evenly 11 times, 1 left over. So I don't typically write that step. I'm going to keep doing it, though. Okay, I'm going to keep doing it because if you're not really sure you know how to do that, then you make sure you keep writing that, what I'm writing. If you can do that, then do that. Okay? All right, so let's mix it up a little bit. Some perfect squares, some non-perfect squares, some variables, some numbers, all together. So this is your process, your thinking process for these questions. Is 64 a perfect square? Okay, so we're going to leave it. Is x to the 11th a perfect square? What makes it a perfect square? It's got to be an even power. So I'm going to break that one to x to the 10th x. So my first step is going to be to break it up if I need to do that. And then I'll simplify. The square root of 64 is 8. Perfect square. The square root of x to the 10th. 10 divided by 2 is 5. And then I have my square root x left under the radical. And then I'm done. All right, 13. Does 13 have a perfect square? Does not. Does 13 have a square factor? 13 times 1. That's the only thing that gives you 13. 1 is a square of everything. We don't use that. Is x to the 12th a perfect square? Yes. So my 13 is going to stay. I can do nothing with it. I can't square root it. I can't break it up. And then on my x, 12 divided by 2 is 6. Done with that. X to the 9th. Is 60 a perfect square? No. So what am I going to break 60 into? This is where I'm going to use my chart. I'm going to start dividing at 49. 60 divided by 49, by 36, by 25, by 16, by 9, by 4. Finally, 4 works. So it's going to go to 4 times 15. X to the 9th, it's got to be even. So x to the 8th x. Now I know this is a lot of writing, and as you work through these, if you really start understanding it and don't have to write as much, that's fine. I'm going to keep doing it though. So square root of 4 is 2. Square root of 15 is going to stay. On my x, 8 divided by 2 is 4. That's a perfect square. And then the x stays. So on my next, 12 is not a perfect square. I'm going to break it to 4 times 3. My x to the 4th is a perfect square, so I'm going to leave it. Don't break it up if it's a perfect square. So on the outside, I have 6x. The square root of 4 is 2. The square root of 3 stays. On my x, 4 divided by 2 is 2. And then I got to put that stuff together. So 6 times 2 is 12. X times x squared is x to the 3rd. Square root 3. So remember, if you have stuff out and you bring stuff out, those get multiplied together. All right, on this next one, 49, perfect square. Yes, Brady?
So there's no, like, multiplication sign or anything between the 6x and 2x?
There is. When it's all like that together, it means multiplication. Yeah. Okay, on this next one, 49 is a perfect square. Do not break it up. X to the 4th is a perfect square. Do not break it up. So I'm going to have the square root of 49 is 7. The square root of x to the 4th, 4 divided by 2 is 2. No things, nothing left under the radical. And then I multiply this together. So negative 28x to the 5th. Negative 4 times 7, x to the 3rd times x squared, add those exponents. Negative 28x to the 5th. And then my last one, which is a biggie. So 20, not a perfect square. I know in my brain, I know from my calculator, I know from my chart that I'm going to break this to 4 times 5. X to the 6th is a perfect square. It's even. Y to the 5th, not, which means I'm going to break it to y to the 4th y. So step 1 is breaking stuff up if you need to. Step 2, square root. So the square root of 4 is 2. I'm just working left to right here now. Each little thing by itself. Square root of 4 is 2. 5 is going to stay. Square root of x to the 6th. 6 divided by 2 is 3. Square root of y to the 4th. 4 divided by 2 is 2. And then my y stays. So again, one piece at a time. Square root it, stays, square root it, stays. And then multiply on the outside. So I have 10 x squared times x to the 3rd is x to the 5th. Y to the 3rd times y squared, y to the 5th, and then square root 5y for my final answer. That's a big one.